Hello everyone, this is Officer Sando. Today I'm going to talk Leetcode 706 Design Hashmap. If you like these videos, you can support me by subscribing my channel or click thumb up for these videos so that wider audience can find my videos. You can find complete code for the problem and the complete video list in description below. So first, let's look at the problem. It's an easy problem. So basically, it asks us to design a hash map without using the internal standard hash map libraries. Then the operator is pretty straightforward. We need to provide put, which is insert the key and value pair. Then also, user can use the get functions to access the hash values by input hash key, and also remove hash key. Then let's look at what's the usage for this class will be. Follow the first example. If you put 1 and 1, of course, it saved 1 and 1 pile, 2 and 2 as well. Then if get 1, we'll return 1. Then if get 3, we'll return -1 because there's no corresponding key there. We put 2, 1, then which means we need to modify the hash value of 2. So then if I get 2 next, it will return the modifier value. Then also remove 2, so the next time you get 2, will return nothing. So here I list the data structure I use to build this hash map and the help function for put and the get. I'll talk to remove for the next page. First, I want to talk to how I select this data structure to store the data. So one thing I want to come to my mind is I want to pick one options to access any hash value given by a hash key. Then thinking about all the standards container I can use, I choose vector since if we have some kind of hash mapping to map the key to a modified key, so then vector index can be used that the after mapping hash values, and we can access that by big of 1. Also, a hash map need to support the handling for the duplication key, so that for one vector index, I could store many hash values. Then also I need to store a pairs of the for one vector index because those hash index can map from different hash key, so I also need to store the original key. So I choose a pair here. Then I need to store multiple pairs for one hash index. Then I need to either vector or list or other container in the nested way of the outside vector. Then the third thing I want to take care is I want a bigger one to remove elements. So to thinking about the vector doesn't have bigger one of operation to remove elements. So here I choose list to store multiple pairs and also has a bigger one operation to remove elements. So next, when we select what the container will be, then we want to do some initialization of containers since we want to pre-allocate some memory to the container. Here I choose 10 power 4 because if you look at the provenance requirements, it will call the put at max 1 power 4 times. So it won't greater than 10,000 hash key in total. So here is why I choose 10,000 as a pre-allocated memory. Then following up, I have a hash function so that it can mapping from the original key to the vector index. Actually, this hash function should go private because it never be called by the user. So so you can make this modification for this to make the whole class definition more clear. Now, let's look at how we implement the put and get function. So I provide the example here. So first we want to put 1, 1, and then put 1001 and 2. The reason is that those two should belong to the same bucket in the vector. Then I want to modify 10,001 to 5, then getting the value there. So input function, I first find out the hash key, which is output of hash value of the original key. Then I'm going to search all the bucket in the vector. If I find the same key, I've just modified the value there and return. Then if I don't find it, I will push a new pair composite by the original key and value. Then for the get function, those options are similar. Get a hash key first, then iterate, find the correct bucket based on the hash key, and iterate all the elements in the list. Then if I find the corresponding key, I will return its value. Otherwise, I return -1, which means I cannot find any bucket given by the original key. So then to implement these examples, first we put 1, 1. So in the first bucket of the vector, because 1 model 10,000 will be 1, will have one pair. It's 1 and 1. So next we put the 10,001 and 2. It will store two pairs in this list. It's 1, 1, 10,001 and 2. And third operation, put 10,005. So basically, we are inside the for loop. Then the first we are finding the first pair. However, its key doesn't equal to the 10,001. So we in these for loops we access the second elements. Then it's 10,001. Okay, we find the key we want. So here, by doing these assignments, we just modify these 2 to 5 to finish this put operation. Then the fourth operation is get 10,001. So in get function, we get a hash key is 1. Then we access all the elements in the bucket 1. So first we access this one. Its key is not equal to 10,001. So we visit the second one. Second is 10,001, which means we find it. Then we output its value here. So next step, let's look at the computation complexity and the space complexity. So we assume number of key will be n, and the number of duplicate key will be m. So the space complexity will be, we have a number of key bucket n, then multiply, sorry, let me rewrite that, m, which means each bucket we will pre-allocate m slots for the duplicate key number. Then for computation complexity of put function, we do find a bucket in the container and access all the elements there. So by max it will be m, right? So because we have m duplicate key slots. So this is design problem. So we need to analyze all the complexity for each API. So put is API here and the get is another API. So as you know, the get function is really similar to the put. So its computation is also bigger of IM. So next I'm talking about remove function. It's almost the same here. Right, the only difference, I think maybe you should, yeah, so the only difference here is we iterate the buckets by its iterator, since we want to remove in the later operation. So here is help us to find the removed elements iterators, so we can directly call the erase for the list data structure. Then here is how it's going. So say right now we have container with bucket 1, and we have 1 pair 10,001 and 5 and the 2001 and 6. We want to remove 10,001. So what we do is we first access the first elements in the bucket 1. Its key is not equal to the key we want. So we visit the second one. Here we find that it's 1. So we will remove this pair, right? So and directly return. So we don't need to visit the third element here. So after we remove the bucket 1 result into 1, 1 and 10,001 and 6. And regarding for the computation complexity, the remove function is the same as get function there. Then the complexity is bigger for n, so we worst case we'll revisit all the elements in this bucket, and this bucket max number will be big of n of duplicate keys. All right, so this is all the implementation of my Hashmap class. Hopefully you like this video. And I see you in next videos, and feel free to drop any comments and any question you have interest for me to explanation. See you.